My name is James Nwai. I am from Nairobi, Kenya, and I am a Google developer expert. And today I wanted to talk to you about deploying and scaling a containerized application on Google Cloud Platform. So some technical stuff there. But I had designed my talk to show you some services on Google Cloud that you can take advantage of, and also with some code samples, and also with some commands that we could have run. But ideally, the gist of this talk was to talk about web development and containers. In my career, I have been a software developer for, I think, 10 years now. And I have seen how, oh, that's a good thing. Thank you. Thank you for that. And in my career, I spend most of my time doing back-end development, working with cloud infrastructure, working with containers, and I have seen, things change from how we used to deploy applications back in the day to how we do it today. And therefore, I'm very interested in exploring more about containerization technologies, exploring more about orchestration of web application, cloud infrastructure, and stuff like that. And that's how I became a GD for cloud. So I spend most of my time, working with the cloud and talking about it. So the most interesting piece of technology in cloud these days is containerization. And containerization is a way in which we package web application and run them on what we call Linux containers. And containerization is like an involvement in how we deploy web applications. Traditionally, it used to be if you want to deploy a web application, let's say you've built something. It could be a website, it could be an API that you want other services to connect to. Traditionally, for you to deploy it on the internet in a place where people can be able to use it, you would launch what we call a virtual machine. In a virtual machine, you launch it. It could be running on something we call like a hypervisor, for example. And then you install the operating system you want on that virtual machine. Then you install the dependencies that your web application requires and the web server that your web application requires. And then it's running full-blown, full OS. And mostly it used to be, for every virtual machine, you're running like one kind of application. But containerization has evolved to improve that aspect. So with containerization, we still do virtualization, but we don't virtualize on operating system level. We virtualize on application level. And what that allows you is you can have multiple instances of different applications sharing the same virtual machine. But each having its own self-composed differences. And that is what something like Docker helps us achieve. So Docker is a containerization technology. There are others out there, but Docker is the most popular today. And what you do with Docker is you write your application just like you would traditionally write it. Then you use Docker and package that into what we call a Docker image. And then once you package it in a Docker image, you are ready to be able to run it on any host in the cloud that can be able to run a Docker image. And you don't run the Docker image, you create an instance of the Docker image, which is what we call a Docker container. And now a Docker container is a running instance of your application. And all you need to do is install Docker on your machine, create what we call a Docker file, use that Docker file to create a Docker image, and then from that Docker image, you can create an instance of your application. Now the beauty of that is you can create multiple instances of your application. And as opposed to if you are running a single instance of your application on a machine, with Docker you can be able to write to create multiple copies based on the requirements that your application might have, whether it's CPU requirements or memory requirements, etc. Now, today, because it's a Google Dev Fest, I wanted to show you some services on Google Cloud whereby once you have packaged your application in Docker, you can be able to run it on quite a number of services. And it's all based on the decision you make or the requirements you have to determine the kind of service you'll choose. So we have quite a number of services on Google Cloud where you've written your application, you've packaged it in Docker, you want to run it in the cloud now, to serve your customers. The first service that you can use is what we call Google Cloud Run. And Google Cloud Run is a serverless platform for running containerized applications. And the way serverless works is you create your image, you push it somewhere in the cloud. We normally call that an image repository or artifact registry. And then you tell Cloud Run to create a service for you using that image. And you can configure Cloud Run to scale up and down the way you want. And it also has some auto-scale configuration present in it, whereby based on the resource requirements of your application, it can be able to scale up and down. It can create additional copies of your application. It can scale them down, all based on how much resources you are needed at a particular time. For example, hypothetically, if you create a container that can handle 100 concurrent requests, you will want to scale it up when you start getting 200 concurrent requests. When you start getting 300 concurrent requests, you want to have 3 copies of your application at that time because the capacity for one is 100. And you can scale up to thousands of concurrent requests that you want. All that is built into Cloud Run. Now, Cloud Run can also scale to 0. When your app is actually idle, like let's say you've built an application for small businesses in Lagos. At midnight, they're not doing any business, so you shouldn't be paying for compute power at that time. That's the advantage of containerization technology over virtual machines. If you create a virtual machine in the cloud, you are always paying for it whether you're serving traffic or not. But with something like Cloud Run, you can be able to scale that up and down. The other service we could have looked at is Google App Engine, which can also run containerized applications. So Google App Engine comes with 2 flavors. We have App Engine Standard and App Engine Flexible Environment. It is started with App Engine Flexible Environment, which allows you to have a runtime that can run any kind of application, whether you're writing it in Golang, PHP, Java, you have all those runtimes. Now with App Engine Flex, you use Docker binaries to run the application. So it's gonna build your application into a Docker image and then provision some machines to run it. And you can also configure it to upscale up and down based on your requirements. So we could have looked at another service called, which was the other service? Google Kubernetes Engine, GKE. Some of you may be familiar with Kubernetes. It's also a way of running containerized applications. And the way Kubernetes works is it creates a Kubernetes cluster for you, or you can create it yourself. And then within your cluster, we have what we call nodes or worker machines. And those nodes are where you run your applications. And Kubernetes is responsible for determining how to deploy or schedule your containers to those nodes. And it can be able to be configured to scale the nodes up, what we call cluster auto scale, or even scale the applications inside those nodes horizontally or vertically. Almost any cloud service nowadays allows you to run Kubernetes clusters. I think pretty much any serious company now uses that. And with Google Cloud, there are 2 flavors of Kubernetes offerings. We have GKE standard. It's the original way of running containers on Google Kubernetes engine. And then there is GKE Autopilot, which is sort of a serverless Kubernetes offering, which means you don't have to manage the underlying nodes. You don't have to manage the scalability of the underlying nodes. You don't have to manage the updates, the security of those nodes. All that is handled for you. All you need to do is write your configuration in Kubernetes and then hand it over to GKE, and it's going to do everything for you. But you can still use GKE standard, and that way, that gives you more access to the underlying infrastructure. You have more access to the VMs. You can configure auto-scaling options the way you want. You can configure resources the way you want. That is GKE standard. But GKE Autopilot is also like a serverless way of running your containerized apps. Another way you can run a containerized app is on Google Compute Engine, which is the service that we use to provision virtual machines on Google Cloud. And it comes with an option to provision a virtual machine that runs on what we call containerized or container optimized operating system. This is an operating system specifically built for running containerized application. It's not Ubuntu, it's not Windows, it's not any of those other things. It's built specifically to run containerized applications. And what you do with the GC, if you want to just run a container in a VM, you tell it to provision a VM, but the OS you want is the container optimized OS. And then you tell it the image you want to run. And with very minimal configuration, like you would have seen, you can have an image, a Docker image built and stored in a registry somewhere, and immediately have a virtual machine running that image and scaling up and down. It can scale, it can add more CPU if you need it, can add more memory if you need it. It has built-in auto-scale features as well. I've never given a talk where I can't see what I'm talking about, but I can give you my GitHub. I'm going to post my slides on GitHub, as well as the source code and the documentation. My GitHub is github.com/jmwai, Jmwai. github.com/jmwai. You can go and follow the how to build an image, how to provision Google Cloud. How you want me to repeat? github.com/jmwai, Jmwai. That's my GitHub. So I'll post. I think I had already posted the documentation there, but you can go through the documentation. I have a README that you can go through, look at the code I've written. I have a test application I've written in Golang, and then I am creating a Docker image from that, and then provisioning that or pushing that to artifact registry, and then provisioning those 5 services that I've mentioned and deploying that application respectively to those 5 services. And the important thing to note is they all are managed services. They have built-in autoscale, and you may decide over time which service is best for you. For example, App Engine gives you more control than Cloud Run. But also App Engine, you cannot use it with a free account. You have to have, it doesn't have a free tier. Kubernetes gives you more manageability to control the way your application is deployed, to control the scalability. That is in your hands, as opposed to Cloud Run, which is built in. So you'll see the limitations for each service, why you would choose one service over another. And I'm going to stop there unless someone has a question.
Can you give us a real-life example why it is beneficial to use reverse proxy?
A reverse proxy.
Yes.
Nginx. Well, I have used Nginx together with, I think, Geonicon. I think the beauty of using a reverse proxy is you can do things like traffic splitting. For example, you can have multiple services running behind Nginx, and then you can tell Nginx where to send HTTP requests. So let's say you have, and Nginx is used a lot with Docker, for example. So let's say you have 3 copies or 3 different applications running on a host. Now you put an Nginx ingress or the reverse proxy, and then you can configure it and tell it, if you see traffic on this domain, send it to that app. If you see traffic on this URL, send it to that app. If you see traffic from this IP, send it to that app. So you can split traffic to your various applications. And it also has built-in load balancing. You can configure transport level security on it. Things that you don't have to necessarily do on the application level. You heavy lift them and do them on the proxy that you're using. You can work as your gateway as well. Yeah. And in the Kubernetes world, we call them ingresses, and Nginx is one of the most popular Kubernetes ingress. Yeah. I think we end there. Thank you so much.